First of all, I would like to thank the organization of the Mathematical Congress of the Americas. My name is Graziela Langone Fonseca, and I will present the work title Wix-Mesh Coproduct. This is a joint work with Eneilson Fontes and Graziela Martini. And the principal idea of this work is find the necessary conditions to turn out the Wix-Mesh coproduct on a Weak-Hopf algebra. I start this presentation by reminding the definition of a Weak-B algebra. This is a vector space such that is an algebra and a coalgebra, and in addition, these three conditions are satisfied. Now let H be a Weak-B algebra. We say that H is a Weak-Hopf algebra if there is a linear map S from H to H called antipode, which satisfies these three properties. Furthermore, the antipode is an anti-multiplicative and an anti-commultiplicative map. A known example of Weak-Hopf algebras is the groupoid algebra. Let G be a groupoid such that the cardinality of the identities is finite, and consider Kg the vector space with bases indexed by the elements of G. Then Kg is a Weak-Hopf algebra with this structure. Here's the multiplication, the unity, the commultiplication, the counity, and the antipode. Another example of Weak-Hopf algebras is consider Dn the vector space of all diagonal matrices with bases EII, where EII is the matrix with 1 in the position II and 0 otherwise. The usual matrix multiplication turns Dn into a commutative algebra with this unity. Moreover, Dn is a Weak-Hopf algebra with this coproduct, this counit, and this antipode. A necessary definition is the definition of comodally coalgebra. Then consider H a Weak-B algebra and C a coalgebra. C is a left H comodally coalgebra when there exists a linear map Rho from C to H tensor C such that these four properties hold. And in this case, we say that H coacts on the coalgebra C. This next result says that if in this definition we consider H as a Weak-Hopf algebra, then these three properties imply in this fourth property. Then here we have two examples of comodally coalgebras. The first one says that it's easy to check that Dn is a Dn star comodally coalgebra via this Rho, where Dn star is the dual of Dn. And the second one says that if we consider Kg the groupoid algebra and Kg star its dual, then Kg is a Kg star comodally coalgebra via this Rho. As you can see here in these examples, they are very simple. then our next step is construct a way to find new examples for commodity algebras. Then I will start talk about the coactions via rho Z. We say that C is an H-commodity algebra via rho Z if for some fixed element Z, the linear map rho Z from C to H times C defines a structure of commodity algebra on C. This next result says that a coalgebra C is an H-commodity algebra via rho Z if and only if Z is an idempotent element and delta of Z is Z tensor Z. Then here we have two examples of commodity algebras via rho Z. The first one says that if we consider Kg the groupoid algebra, thus fixing an element E on the identities of G, rho delta E ensures a structure of Kg commodity algebra on any coalgebra C. And the second one says that for any coalgebra C, it's easy to check that C is a Dn commodity algebra via rho EII. Then this next definition is the definition of weak-smash coproduct. Let H be a weak B-algebra and C an H-commodity algebra. The weak-smash coproduct was defined being the subspace of C tensor H given by C times H. Furthermore, C times H is a coalgebra with this coproduct and this counit. As I said, the principal idea of this work is find the necessary conditions to turn out the weak-smash coproduct on a weak Hopf algebra. Then, this next definition, we will see some extra conditions for this weak B-algebra H and for the coalgebra C. Then let C and H be weak B-algebras. We say that C is a left H commodity algebra if there exists a linear map rho from C to H tensor C such that rho defines simultaneously a structure of left H commodity algebra and left H commodity algebra on C. From now on, we will consider C as an H-commodity B-algebra. Then we will have some lemmas about C times H. The first one says that the coproduct on C tensor H induces a product on C times H given by this rule. And as a consequence, 1 of C times H is 1 of C times 1 of H. Under these conditions, the coproduct defined on C times H is multiplicative. Another lemma says that if C times H is the weak-smash coproduct, then the counit on C times H satisfies these properties. And the last lemma says that if C times H is the weak-smash coproduct, then the property of the counit of the unit of a weak B-algebra is satisfied for C times H. Therefore, we will obtain this result that says that If C is a weak B-algebra and H is a commutative weak B-algebra such that C is an H commoduli B-algebra, then C is a weak B-algebra. Therefore, we will obtain the wanted theorem. Then let C and H be two weak Hopf algebras such that C is an H commoduli B-algebra and H is commutative. Then C times H is a weak Hopf algebra. The next step is find some examples that satisfies this hypothesis. Then we have this result that says that if we consider C and H two weak Hopf algebras such that H is commutative and C is an H commoduli coalgebra via rho Z, then C times H is a weak Hopf algebra with pointwise product and coproduct, counit, and antipode given by these rules. Then we have an example to illustrate this situation. Consider C as a weak Hopf algebra such that C is a Kg commoduli coalgebra via rho delta I. If Kg is commutative, then C times Kg is the weak Hopf algebra with pointwise product and coproduct, counit, and antipode given by these rules. Finally, here we have the references. Thank you for your attention.